And welcome to our bonus features segment. First thing we're looking at is the likelihood of GPS errors, and we're seeing some pretty wild swings here in the electron flux. Check it out right there over the Middle East, the Western Indian Ocean, and the African continent. We're seeing a sudden reduction in the total electron content. Now, this is the total electron content from the thermosphere, ionosphere, plasmasphere, and it's calculating electrodynamics. The most likely place for GPS errors is indeed around the equator at noon, but sometimes we see some chaos. We're seeing right in this area here, seeing a big reduction in the electron flux there over the African continent. And then you can see a return to more normal levels of electron flux there over the Atlantic Ocean. I'll let it play through one more time here, and then we're going to blast through additional bonus features. So what we're looking at there is the electron content in the plasmasphere and the other plasmasphere and the Van Allen belt and the thermosphere. So this area right here, your GPS has to communicate with your handset, and too many electrons can cause error. So we're seeing some charging hazards as well over places like Central America and Mexico, especially also the Central Pacific, some more minor charging hazards. And if you want to read about that, just click on details here from the CSERT page. Just click on details, it'll tell you all about that. Those surface charging hazards are caused by low energy electrons, which build up on the surface of satellites and can cause some errors. Here's the one-year chart of the relativistic electrons. We're expecting an uptick here once this coronal hole wind stream subsides. And we are already seeing that start to happen here. So there's a 3-day chart measured by the GOES 16 and 17. They're measuring the electron they're measuring the electron content at the F layer from their geosynchronous orbits. Here's the forecast model. Green boxes are the forecast. Yellow diamonds are the observation. NOAA getting pretty close to the most recent forecasts here. Next, we'll show the ionosphere. And the F layer, again, is where the GOES 16 and 17 make their measurements. Here's the ionogram, the animated ionogram for the ionosphere over the previous day. There's a lot of vibration going on above your head, especially around the equator at noon. And here's a visualization of that. It's the bridge between Earth and space. Here's the anomalygram, showing the anomaly at megahertz from the 30-day median. Remember, folks, March is the second most geomagnetically active month of the year after only September. Yeah, the equinoxes, Earth's equinoxes, are more geomagnetically active than the period around the solstice. So we can expect additional exciting stuff coming on the channel. Here's your recap. There's 11:30 Universal Time. Lots of high-frequency anomalies happening there at the moment. They're pretty obvious to me and our regular viewers probably as well. And there you can see those high-frequency anomalies over places like Western South America. Low-frequency anomalies happening east of the Drake Passage. One of the weirdest places in the world, by the way, folks, the Drake Passage. This area right here, where the Atlantic and Pacific Oceans try to reach static and thermal hydrodynamic equilibrium. It's just a weird place. Anyway, welcome to the Neo Renaissance. Congratulations on realizing the channel exists. Please visit our link, support the channel. We're writing a paper explaining the solar polar field reversal cycles and sunspot cycles. Thanks to the Smash team, today's featured product is Mensa. Yeah, I'm wearing the hat, see? Mensa. It stands for Make Earth Not Suck Again. If you've noticed Earth sucking, well, it's up to you to make it not suck again. Tell your friends and foes about it. Thanks to our viewers in places like Tasmania who've purchased Mensa logoed products. Yeah, they're available all around the world, folks. You don't have to be in the U.S. You could probably even order these in Belarus. Shout out to Mr. Bagashov. Mensa. Make Earth Not Suck Again. It's up to you, not giant bureaucracies that can't even get out of their own way or do their own jobs. I'll tell you somebody who can do our own jobs, the Smash team. Thanks to the Smash team. Thanks to Smash staff for setting up the website. Did you know my forecasts continue to come true? If you want to read about it, you got to become a gold member. Smashamash.com/Smash team. We replace Patreon with something superior, our own subscription services site. Next, the latest ground-based solar observatory data here from the ground-based National Sunspot Observatory Center at Cerro Tololo, Chile. Again, lots of filaments on the Earth-facing side of the solar disk. Don't be surprised to see some coronal mass ejections here. You can see some filaments actually activating up here. Some movement, we could be seeing a CME happen as we make the video. Filaments down here, prominence up here, that's a filament as well. Absorption features. Solar filaments. What do you think? Will they eject soon? I've got no comment. We used to forecast coronal mass ejections. We decided to stop because if it don't make dollars, it don't make sense. Sunspot 2953 has grown. Make sure you watch our previous video if you want to see more detailed information about that. It's now a beta gamma class sunspot, and the likelihood of solar flares has gone up with that. There's Sunspot 2954 and Sunspot 2955. They're large. They're not beta class. They're only alpha class. They have a simple field structure. As you can see, they're both North Pole-oriented sunspots. This one has got both field polarities, and it's actually more likely to produce large flares than those large sunspots. Now, keep in mind there is a lot of plasma suspended around Sunspot 2954 and 55, as you can see quite well here in the GOES 16 SUVI imagery. Likelihood of coronal mass ejections, very high. Very high. And we'll close out with some more animated imagery here of the closest star. Thanks, stargazers, for tuning in. This is 335 plus 1700 angstroms. Here are the two best wavelengths through which to view solar flares, 131 and 94 angstroms. It's all part of the ultraviolet light spectrum, folks. That's ionized iron gas at, let's just say, very hot temperatures. The electrons can't even hold on. And we'll close out with a full disk view in these same wavelengths. Thanks for tuning in. Don't forget to press like and subscribe if you enjoy the content. And may that solar wind be at your back.